Hello friends, I am Dr.V Pandey, Head Department of Physics, Shivaji Arts, Commerce and Science College Kannad. Now, this is gas field ionization detectors. A nuclear detector is an instrument used to identify, detect, record the intensity, mass and energy of the nuclear radiations. The nuclear detectors are based on the ionization of nuclear radiations with matter. It has two basic parts, that is, detector in which the interaction of nuclear radiation takes place and the measuring device which accepts the output from detectors and then measure the properties of nuclear radiations. The gas field ionization detector functions by generating electrical signals by the ionization produced in the detector due to the interaction of incident nuclear radiation. The sensitive volume of the gas is subjected to the electrostatic field generated by applying a suitable potential difference between two electrodes placed in the gas. These detectors are classified into three types. Number one is ionization chamber. In these detectors, the electrostatic field collects only the charge ions produced by the interaction of the nuclear radiations. Second one is proportional counter. In these detectors, the electrostatic field is sufficiently high to give an internal multiplication of the initial ions produced by the nuclear radiations so that the total number of the free charge carriers generated during the multiplication is proportional to the initial number of free charge carriers directly created by the nuclear radiation. And the last is Geiger-Müller counter. In these detectors, the electrostatic field is much high than the proportional counter. Here the chamber of free charges produced by internal multiplication no longer retain the proportionality to the initial charge carriers. Therefore, the electrical signals obtained from the GM counter does not contain the information about the energy loss of the incident nuclear radiation. Now the variation of ions collected with increasing the applied potential is given by the curve from these three regions can be explained. These are shown in figure. This is applied electrostatic potential and this is number of the ions which are collected. Now the first region is a ionization chamber. In this region ionization is produced. Second region is proportional counter. This is second region, proportional counter, and when electric field is very high, then this region is called as GM counter, or it is also a Geiger-Müller counter. Now, proportional counter. This is tube proportional counter. The proportional counter consists of a cylindrical glass G that contains metal cylinder M and a thin uniform tungsten wire C well illustrated from cylinder mounted coaxially within the metal cylinder. The central wire serves as an anode and the outer cylinder serves as a cathode The glass tube G provides support for both the central conducting wire being supported through an insulating plate P. One surface of the glass tube acts as a window W, and electrical connections are taken out from the other surface. The tube contains a gas at a pressure of about 2 to 10 mm of mercury. The gas being a mixture of 90% argon and 10% of ethyl alcohol. A high potential difference is applied to the two electrodes of the tube through a high resistance R. The central wire is also connected to an electric circuit consisting of amplifier and analyzer. When a particle enters through window W, it collides during its passage with a gas molecules and ionize them, producing number of the pairs of positive ions and electrons. The electrodes having opposite polarity attracts each ion. This makes electron to move towards the central wire and positive ions towards the outer cylinder M. But the ions acquire energy from the attractive force and get a capability of ionizing other gas molecules with which they collide on their way towards the electrodes. The successive and multiplicative ionizations lead to available. The avalanche generation due to the electrons is permanent. As being light, they move fast and get more chances of collision with gas molecules. Now, next is GM counter. Now, construction of GM counter is shown in this stage. Here, potential difference is very high. Now, construction the Geiger-Muller counter consists of GM tube, high voltage power supply, and electronic counter. The GM tube has outer metal cylinder M and very thin tungsten wire C. Located along the axis of the metal cylinder. The central wire serves as anode and outer cylinder serves as a cathode. Now working. When a particle enters through window W, it collides during its passage with some gas molecules and ionize them, producing some number of the pairs of positive ions and electrons. The electrode having opposite polarity attracts each ions. This makes an electron to move towards central wire and positive ions towards the outer cylinder. But the ions acquire energy from the attractive force and get capability of ionizing other gas molecules with which they collide on their way towards the electrodes. When current is circulated through the outer circuit due to the collision of the ions, the tube, the current passes through resistance R and drop some voltage across it and decreases the voltage applied to the tube electrodes and stop the discharge in the tube. The presence of polyatomic gas and series resistance help in resetting the tube and making it ready for the next detection. The counter measures the pulses generated due to the passage of particles, one pulse being generated by one particle. The number of pulses counted gives the number of the particles that entered in the tube. Uses the GM counter is used in detecting varieties of particles like alpha particle, beta particle, and gamma rays and cosmic rays. It is highly sensitive. It responds even to particle that is capable to producing single ion pair initially. The counter life is infinite and can be used for long duration, but it is unable to give an idea about the nature of the charge or momentum of the particle. Further, if two particles enter quickly, one after another, they are detected as one. The GM counter is useful in the study of radioactive material, particularly the quantitative study of the radioactive radiations. It is also useful in cosmic rays studies.